Alright, so today we are on day 1, lesson 8.1. So now we're into the chapter, we're done with our preview of it. So we're going to put it all together. I would keep your little orange foldable to go back to and review it. So we do the warm-up. Evaluate x to the fourth when x is 3. So I'd have 3 to the fourth power, which, what does that equal? Three to the fourth power. What would that equal?
No.
81. So it's like 3 times 3 times 3 times 3, which is 81. Remember, you could do this and say 9 and 9. Or you could have done 3 times 3 is 9, times 3 is 27, times 3 is 81. 8 to the second when a is negative 6. So negative 6 squared. And that would give us
12. Wait, no, 36.
positive 36. And then m cubed when m is negative 5. So it's going to be a negative because what? Because it's an odd exponent, so it stays negative. And then what was it?
Negative 125.
25. Okay. Now, I want to show you guys something quick to help you, especially with some of your homework where you get the big numbers and it's to like the 7th power and it gets too big. If, as long as you understand how we're writing these out, like negative 6 to the second power is negative 6 times negative 6, and we understand that. If you use your calculator, and this is how you use exponents on it. Let's say we were doing 8 to the 12th power. Alright, and so when you go to simplify this, you don't want to do 8 times 8 times 8 times 8, and you write that out. If you do in your calculator, here's how you do it. You do 8, and then you see up here this is squared, so that would have been like 64, right? Where's my clear? What we do if our exponent is different than the 2, I say x, and you see the one that says x to the y power? So you push that one, and they give you that little up caret looking thing. So it says, okay, what is your exponent? So my exponent is 12. And I say equals, and it will solve it for me. Okay? So let's check to see if this works. Let's do one we know for sure. 3 to the third power. 3 to the third power is 3 times 3, which is 9, times 3, which is
27.
So if I check to make sure I do this right in the calculator, we put in 3, x to the y, give me the little up thing saying here's your exponent up here, and we say to the third power, we get 27. Okay? So if you need that help when you're doing some of these problems, because I know a few of them, that's why we left it as the exponent set in our homework, because it was like 15 to the 5th power. Well, I don't want to do that or something. All right. Let's work on today's. Powers of powers. Hey. Mine didn't. Like when I did this at home over the weekend, I put in a picture again, but it didn't show. Must not. Am I on mine? Okay. Ooh, I wonder if I did it on someone else's yesterday. I probably did. Alright, so powers of products. Make sure you use your little graph thing to help your graph. Your foldable if you need. But remember our rules. If we are multiplying here, you're going to keep the same base. So x to the third times x to the fifth will be x, and you add your exponents. X to the third, x to the fifth, 3 plus 5 becomes 8. My final answer is x to the 8th power. Go ahead and just do this one. Do the next two. Just see if we're on the right page. The right one is the one I think we're going to make a mistake on. So go ahead and do the y, check with the neighbor, and then do z, and then we'll talk about it. This one ain't too hard. The z one, I think I'm going to have a couple people make a mistake. Okay, see Moses. What do we put for y? What would this be? Y to the 11th. Very good. It stays the same. Remember, this one is still like y to the first power. They just didn't write that. So it would have been 1 plus 8 plus 2 is 11. What about the last one? Z to the 7th is incorrect. Negative Z.
Negative.
Okay. Remember that we are checking our base is staying the same. Our base was negative Z. I want to do this too, and it's still hard for me not to because I see Z, negative Z, negative Z. Negative times a negative is a positive. However, if it's 7 times, that's odd. It's going to stay as our negative. Huh? Oh, there's no picture. That's awesome. So, there was our little reminder. Okay, let's scroll down to the next ones. This is kind of what we worked on yesterday. Powers of a power property. I put on, well, when I say yesterday, I mean the last math class. So, powers of a product. Add x to the 5th, and then all that is cubed. If you look at my second picture, I used this one, because this is really to visualize what's happening. When I have x to the 5th cubed, that means I have x to the 5th times x to the 5th times x to the 5th. Well, we just did these. Well, we just did this right here, product of powers. We know that our base stays the same. So I'd say x, and then I add my exponents. 5 plus 5 plus 5 is 15. So my answer is x to the 15th. The shortcut, if we understand this, the powers of a power, I can just do the x stays the same, and I multiply my exponents. 5 times 3 is 15. Okay, what about this one? What do you think we're going to have to do first? We have negative y in parentheses, and then we're squaring it, and then we're putting brackets around, and then we're putting it to the 5th power. Okay, what do you think we do first? Nope. But to be honest, it's not. You can't. You guys see why. But what should we do first? Very good. Yeah, we want to work with our exponents on the inside first. On this example, there's nothing else inside the parentheses, so it's not going to matter. But we want to go with what's inside our parentheses first. Parentheses is first because of PEMDAS. The only thing in parentheses is negative y. So then we look for our exponents. So negative y, now I'm going to look at this, squared. That will give me y squared. Why does the negative y become positive y? Mainly, the best answer would just be our exponent is even. Remember on Friday? If our exponent's even, the negative becomes even. If it was a negative, it stays negative. Then, we still have our brackets. NB to the 5th. So then this final answer become what? Y to the what? 10. So on this next one, parentheses first, we have y plus 2. We can't solve. But we have it to the 6th power. So do it step by step. What would this simplify down to? Y plus 2 all to the 6th power. Grace?
Y to the 6th power plus 64.
Plus. And it'd be 2 to the 6th, which 2 to the 6th. I'm not sure off the top of my head. That sounds kind of big though. 2 to the 6th. I didn't question you, I knew it. So, y to the 6th plus 64. Oh, made that 4 really big. Okay. But then we still had our brackets on there with this exponent. And so now what would this simplify down to? So we have y to the 6th plus 64 squared. What will this simplify down to?
Y to the 12 plus 64 to the second.
Y to the 12. The 6 times the 2 is 12. And then plus 64 squared. Did you not do 64 times 64 in your head? So times
4,096.
46.
That's what I got.
Okay? Not too bad. You're going to continue this. Go ahead, do these 3. I'm going to pause. I'm going to walk around and see how you guys are doing. See if you can solve these. Okay, so what do we get? 9xy all to the second power. Rahab, how'd you do this one? What'd you get?
I got 81, and then x to the second power, and then y.
Very good. So you would have squared every single thing. 9 squared is 81, x squared, and then y squared. Negative 4z squared. Heckman, what'd you get? 16z squared. Good. Last one might be tricky. What looks different on this one before we start it? Just to make sure you guys don't make a mistake. Maddie?
The C, negative before the 4.
So the negative's outside the parentheses though, right? Make sure you pay attention. Because the negative sign's outside the parentheses, it's saying, what is the opposite of 4 times z squared? So I first solved 4z squared, which is 16z squared. But then it said, what is the opposite of it? So negative 16z squared. Okay, make sure you don't put the negative in beforehand. Okay, only a few left. This one, you're going to be mixing all 3 properties together, or all 2 properties together. So, I'll do the first one with you. What I'd see is 2 times x cubed, all squared, times x to the 4th. Remember, if you ever get confused on whether you're going to add or multiply what you're doing, remember, I could take this right here, and over here, I could be writing it like this. Because that's what it means to square. It means take it times itself. Because then I just do the common things. 2 times 2 is 4, and then x stays the same and add the 3, so x a third. Or, we distribute it. 2 squared is 4. X cubed squared is, you multiply your exponents, so x to the 6th. And then I still had timesing by x to the 4th power. So when I solve this one, I now have 4 still stays by itself. I have the same variable, so the same base. The base stays the same. You add your exponents. 6 plus 4 is 10. That is my answer. Go ahead and do B, C, and D is our difficult one. See what you can do with it with the partner. Alright, so first one on B, we had 3 to the 5th in parentheses squared. So what would that part have simplified down to? Tatum, what would you have done on that one? 3 to the 5th power squared.
I made it 243 squared because I'm 3 to the 5th power.
Okay, so you did 3 to the 5th power first. Okay, and then you squared that. You could do that and you end up with the same thing. What I would do first is, since I know I'm going to have the exponent, I would have left this the same and said 3, and then 5 times 2 is 10. And then I'd have 3 to the 10th power. and then you can go ahead and put that in your calculator if you want. This is one that probably not going to, because my numbers are going to become really, really big. What about negative 2 to the 7th power? My first question is it going to say negative or positive?
Negative.
And it's negative because?
It's all.
Because it's what?
Odd.
Why is it odd?
Well, the exponent.
Alright, good. The exponent is odd. That you just meant like it's goofy. Okay,
Yeah,
so this, I can get to be negative 2 to the 7th. Honestly, could we use our calculator and say 3 to the 10th power is some giant number, and negative 2 to the 7th power is some large number, and then multiply the two and get one really large number? Yeah. Or, I'm okay if we leave it as 3 to the 10th times negative 2 to the 7th. You may leave it like that. I'll double check when I need you to multiply it all the way down. I want just the exact answer. If possible, like this one, I'll let you know for sure.
On the 3/5 squared, could you also have done 6/10? Or no?
No. Because you're not doing no. Because this is 3/5 squared. This is meaning 3/5 times 3/5. And when we write it like that, you can easily see this part is going to stay the same. We have the same base. So our base stays the same, and you just add the two. Okay. The only time when we did that 2 and we took the 2 squared on the other one was something like this one on A. We had 2 times a number that was also having an exponent. Okay? So don't do squaring this and squaring that. Yes?
So on our homework, we don't solve for like the big number every one like that.
No, just leave it like this to the exponent. Okay, C. So now we have negative 10 times 15. So negative 10 was in parentheses, so we know it's negative 10. And we're taking that times 15, and that's all in brackets. And then cubed. What do you think I should do first? We want to do our parentheses first. PEMDAS, parentheses. My first thing I want to solve is the negative 10 times 15, which gives me negative 150 cubed. So, is this going to be a positive or negative number? Negative, because Daddy thinks it's odd. And then we'd have negative 150 cubed. I'm not going to make you find that large number right there. Okay, here's the trickiest one. This one is actually, I kind of halfway thought it was fun to do. But, when we do this, it's just, all they're doing is trying to confuse you. So this is where your organization comes in handy. Remember, this number, this negative, that's going to come afterwards. It's saying what is the opposite of negative c to the 4th, d to the d times e to the 5th, all cubed. So remember, this is like right here, since it's being cubed, that is like I have negative c to the 4th, d e to the 5th, and I have it 3 times. So we could look at it that way, and I could just write this down 3 times. Or we can go ahead and distribute this. So when I do, I'm still going to have a negative out here, and I'm going to put this in parentheses. I'm going to have negative c to the 12th. We'd have d to the 3rd. And we'd have e to the 15th. Does that all make sense so far? Not too difficult, right? The next one is, let's distribute the 2 to this. C squared. D would become 7 times 2 is 14. And to the e to the 12th. Okay. Before we go on, let's get rid of this negative now. Because now this has to go in there. So when I do the negative times everything in here, I'd have c to the 12 d, oops. The d is going to be negative, and then negative e to the 15th, because we're distributing that negative through. As I said, what is the opposite of this? And I still have, I'm going to switch colors so we don't mix them up. I still have c squared e to the 14th e to the 12th. All they're doing is giving us a box. They're trying to confuse us to see if we understand the process. Now that I have all this multiplied, c to the 12th times negative d to the 3rd times negative e to the 15th times c squared times d to the 14th times e to the 12th. What do we have to look for? What? Yeah, mainly our common stuff. We have to look for our bases that are the same, our variables. So if I start, first letter is C. So this would be C. And what do we do with the exponents when I'm multiplying the C12 times C to the second? Yeah, 12 plus 2 is 14. After C, we look at our D. Now I have a negative D, I have a positive D, and it's going to be 3 plus 14. So that's going to be what? 17. Is it going to be a positive or negative D? Negative D to the 17. And then we have a negative e to the 15th and a positive e to the 12th. And it's going to be negative e to the 27th power.
Wouldn't it just be positive d to the runner?
No, because, okay, good question. Josie's asking, why wouldn't this be like d to the 11th? Because remember, what we're looking at is when we're squaring or using our exponents like d times d times d, we're not adding and subtracting right now. So, like over there, if you put 2 in for it, it'd been like 2 cubed, which would have been 2 times 2 times 2, which is 8. And then d to the 14th, and we're still having 2 times 2, 14 times. We don't subtract our exponents yet on this because we're multiplying. When we're multiplying them, we're going to add them. Okay, I'll show you. I'll write out an easier one with you with smaller exponents as well. Okay. All right. Let's see. We have a few minutes. Find the missing exponents. Go ahead. I'm going to pause our video. Work with the partners. See if you can do this, and then we'll come back and check it. Okay. This one. We're skipping this because we're almost out of time. I'll do the other ones. Mainly in this one, it said they collected data in 10 to the cube colonies. So they're just saying like a really large number. Over here, if you need to pretend, just say they used 2 colonies. Just to make sure you're doing this right. Say they did 2 colonies. And in each colony, there's 10 to the 4th bees. We'll say there was 3 bees in each colony. If I would have said they did 2 colonies with 3 bees in each colony, how many bees did they get total? You would have said, well, 2 colonies, 3 bees in each colony, you'd have done 2 times 3 is 6. So here, all we're doing is 10 to the 3rd times 10 to the 4th, which gives us 10 to the 7th bees. The 2 times 3 was just an example. All right, your homework. 492, number 2, 14 through 44, even. 48, 50, 56, even. It's like 12 questions.